Good morning, everybody. I want to talk about the future of Arbitrum. I want to talk about where Arbitrum is as a typical and I think the most successful layer 2, and more importantly, where we're going. But I want to start with the first rule of Arbitrum, which is your chain, your rules. What that means is that the Arbitrum technology is not a single thing. It's not the goal to impose some kind of top-down uniform governance system across all Arbitrum chains. The idea is that each chain should be able to make their own decisions about what they want to do, how they want to set the parameters, which upgrades, which software versions to do. If you're in the Arbitrum ecosystem, you can have your own chain, and you can set the rules for your own chain. And for the same reason, the flagship Arbitrum 1 chain is controlled completely by the Arbitrum DAO. Okay, now, I want to put these statistics up because I think people often don't realize to what extent the layer 2 roadmap of Ethereum has succeeded. Today, layer 2 and layer 3 in the Ethereum stack accounts for about 30 times the transactions per second of layer 1, about 80 times the gas usage, about 40 times the call data, spread across more than 50 L2 and L3 chains. So to first approximation, almost none of the activity in the Ethereum stack happens on layer 1. And yet today, many of the conversations about blockchain design in the Ethereum stack are focused on layer 1. In fact, what people find even more surprising is that the majority of activity in the Ethereum stack happens at layer 3. Layer 3 is the most, layer 2 is in second place, and layer 1 is far behind. So we're in a different world. All right, but where do we go from here? We've gotten there through the sort of initial rounds of L2 and L3 design. Moving forward, I want to talk about a bunch of features that are coming to Arbitrum or are on the horizon. Stylus actually launched yesterday, Bold, and I'll talk about a bunch of these. Okay, so first let me talk about Stylus. This just went live on mainnet yesterday, and I think it's it's one of the biggest upgrades that has ever happened on Arbitrum. I think it's one of the most important, perhaps the most important upgrade in the execution model in the Ethereum stack that has happened since the invention of the EVM. It's the next generation programming environment for Arbitrum chains. What it lets you do is it lets you write smart contracts in a broad variety of programming languages, Rust, C, C++. You can compile them to WebAssembly and then deploy them directly to an EVM compatible chain. And that's the key. It's not a separate chain, it's not a separate silo. Smart contracts can be written in any of these languages, and they're fully interoperable and composable with EVM contracts. EVM can call Rust, Rust can call C++, C++ can call EVM. All of this works together seamlessly on the same chain. And not only that, so for example, here's a code example written in Rust. It calls a standard Rust library, which of course you're perfectly able to do. And you just decorate the code with this decorator here telling the compiler toolchain to compile this to run on Arbitrum, and it works. You can deploy that as a contract. The other big unlock here is performance. Because a WebAssembly virtual machine is so much more efficient than EVM, and because the Rust compiler generates more efficient code than the Solidity compiler, you can get up to 70x improvement in computation speed. Thomas mentioned Renegade Finance. They launched their application on Arbitrum yesterday using Stylus. Their implementation uses secure multi-party computation. That is too computationally expensive to do on an EVM chain. It simply can't be done. But on Stylus, they can do it and deploy it. And so they are the first significant application to deploy on Stylus. They literally were waiting for Stylus to go live on mainnet. That's the kind of unlock that you can get. That went live, as I said, yesterday on the Arbitrum 1 mainnet. It's available to all other Arbitrum chains Under the your chain, your rules principle, each chain decides for itself whether to adopt this. The next big upgrade that's coming soon, assuming that two chains that choose to accept it, is Bold, which allows efficient and fully decentralized proving in an optimistic proving framework. It's the first and only fully secure, fully decentralized fraud-proof mechanism that will allow this, I think, incredible guarantee to be provided that any one user, that could be any of you, is able to enforce the safety and progress of the chain using equipment that you have. That's what Bold unlocks, and Bold is, it's been well through testing, it's been through audit, and we expect it to be before the Arbitrum DAO for a vote before long. Those are the things that are definitely firmly in the pipeline. What else is on the horizon? There's a bunch of areas. Pushing performance, pushing the amount of throughput you can get on one chain is a big part of that. Stylus is an important step because it makes execution, fast execution available if you use Rust or C++ or one of those languages. Working with alternative client integrations. Currently, the stack uses Geth, but integrating with other clients, perhaps Reth, Aragon, Nethermind. We're looking at that to try to understand how much performance you could get and which of these options looks best for the community. There's a lot of interesting work to be done about more efficient pricing and more efficient resource limiting. The gas accounting system and the gas limit and pricing system on Ethereum is essentially a way of regulating how much activity can happen to make sure that nodes are able to keep up. Well, by doing more precise and more clever accounting and limiting and pricing, we think that you can squeeze a significant amount more performance out of the same nodes. Because nodes currently are not running at their capacity. Even the sort of minimal 4-year-old laptop nodes are not running at their full capacity all the time. And the next piece of this is cross-chain interoperability to allow fast and trustless interoperability across chains. That allows you to do horizontal scaling, where you can get more activity on your application by launching a bunch of sharded chains that interact closely together. There's a whole set of sequencer improvements. Let me talk about that a little bit. The Arbitrum sequencer today has a really unique set of advantages. Fast response time for user transactions, a fraction of a second. Very fast arbitrage time. That makes DeFi markets operate very efficiently. It almost never reorgs. In the entire history of Arbitrum, there's been one reorg affecting 3 transactions. You protect users from front running and sandwiching by hiding the mempool, and the approach is simple, fair, and easy to understand. But there are 2 more things. That's all true today from the Arbitrum sequencer, but there are 2 more things we want. We'd like to be able to internalize MEV value that is generated on an Arbitrum chain for the chain and the chain's owners, whether that's the DAO or an application, and we'd like it to be fully decentralized. So first, Time Boost is the proposal to capture and internalize MEV revenue. The idea is pretty simple: to create an sort of express lane in the sequencer, to use the current first-come, first-served sequencing, but delay the non-express transactions by 200 milliseconds. It's a kind of virtual co-location that says, if you're in the fast lane, if you're in the express lane, you can get your transaction in a little bit faster than everybody else. And then each minute you auction off control of the express lane. Whoever is the high bidder, they pay to the chain owner, and then they get to control which transactions can come in through the fast lane. What that means is that you're guaranteeing that if there's a race to capture arbitrage or to back run or some liquidation, something like that, that the party who has bought these rights will win any race that they compete in. And so you can capture the value of that MEV by auctioning off those rights. This captures the MEV revenue. It doesn't sacrifice any of the green checks, any of the good properties of Arbitrum sequencing that I talked about before. So now, once Time Boost again is, the implementation is finished, and we expect it to be before the DAO for decision quite soon. So assuming that your chain chooses to adopt Time Boost, you can have the next green check to internalize MEV value for your chain. Decentralizing sequencing is the next piece. And this is, and we have a very active collaboration between Offchain Labs and Espresso Systems to develop and implement a decentralized sequencer for Arbitrum. The idea is, this is well underway, and the work to engineer and actually write code for the system is now starting, the protocol having been designed. So what this does is it takes the currently centralized Arbitrum sequencer, which is trusted today for just one thing, which is to report which transactions have arrived and in which order, trusted for only that and nothing else. But to take that sequencer and to divide it up among a committee of sequencers so that as long as a suitable majority of that committee is honest, that you get all of the good properties and users are still protected. But you get stronger resistance against misbehavior, censorship, and other kinds of bad activities by the sequencer. So this is underway. It's a current research project we're not yet at a point where we're talking about dates for this. Okay. The last thing I want to talk about is ZK proving and universal fast withdrawals. When we started Arbitrum, we made a very pragmatic decision that we were going to use the technological approach that best solved users' problems. We were sort of unique among companies in this space in that we did not build the name of a proving technology into the name of our company or our product. We weren't optimistic this or ZK that or Stark this or anything like that, right? The company was Offchain Labs, the product was Arbitrum, because we were not married to any particular proving technology. We chose optimistic proving because it was the best fit for the needs of the user community. And we're really happy with that choice. It's still the right choice today. But the cost of ZK proving is coming down over time with cryptographic improvements. And although it's not yet the case, we can see the day coming when ZK proving may be affordable to do at the cost and with the scale that Arbitrum processing demands. So we want to be ready for that. It'll likely be possible soon to ZK prove single Arbitrum blocks on an ordinary laptop. It'll take quite some time to do that, but it unlocks some interesting options in designing an optimistic protocol. But, and apologies for the typo here, we can see a world coming where well-resourced parties, that means parties who can afford to pay for a lot of AWS or similar instances, who can afford a lot of infrastructure or can buy some racks of special purpose hardware, where those parties will be able to ZK prove the whole chain at full speed and at reasonable cost. Because ZK proving can operate with massive parallelism, it's not really so much a question of whether you can ZK prove the execution. The question is, can you do it at a cost that is reasonable that we think that the chain owners would be willing to pay? We're not yet there. We're not even an order of magnitude from there. But we can see this coming. And so there's been a bunch of work going on in the community to understand how to take ZK proving on board when it is ready, when it is cost effective. And I at least am strongly convinced that the right approach is to adopt a hybrid protocol. Not pure optimistic, not pure ZK, but something where each user, each participant in the protocol can choose whether to take the ZK path or the optimistic path. Essentially what you do is you run something like an optimistic protocol where parties can post claims and they'll be resolved through when time is elapsed. But at any time, anyone can provide a ZK proof to accelerate that process. That allows well-resourced parties to guarantee fast withdrawals, fast settlement to a parent chain in the common case, but it also means that an ordinary user who doesn't have a rack of equipment and isn't willing to pay a huge AWS bill can still guarantee that, provide that critical guarantee of providing safety and progress of the chain all on their own. So this we think is the right way to go with ZK proving, and frankly it's a matter of research, both inside and mostly outside our community to get there. co-processors and cross-chain interoperability, there's a bunch of interesting things there. I'm going to fast forward through this because I see that my time is just about up. We can, yes, we can make cross-chain interaction faster than finality, and there are lots of interesting trade-offs there. So if I want to leave you with any one impression from this, it's that innovation in the design of the Arbitrum protocol and system and in L2 generally is accelerating. We're only going to see more and more progress as the community gets larger and more sophisticated. But all of this, of course, is always in the service of this principle of your chain, your rules. The goal is to create options for the DAO in running its own chains and for each app chain developer in operating their own chain. And I am obliged by law to close every talk with this meme. Let's build Arbitrum together. Thank you.
Thank you.